Today we're going to look at how to solve inequalities. The difference between an equation and an inequality is an equation uses an equal sign. And we've talked about it can have three solutions. One solution, no solution, or infinite solutions. When we're looking at inequalities, we're going to use one of four signs. We could use a less than, greater than, less than or equal to, or greater than or equal to. Our answer is a range of numbers, so x is greater than 5 means all numbers greater than 5. You're also going to have an example that's similar to no solution, which we'll look at later. Create a little chart to discover when we need to reverse the sign when solving. So we're going to create a table, looks like this. We're going to start with the inequality 10 is greater than 4. We're going to perform a specific operation to it. And we're going to look at what happens to the result. And do we need to switch the sign? If I add 5 to both sides of 10 is greater than 4, this gives me 15 is greater than 9, which is a true statement. So we keep the inequality sign. We keep it as a greater than sign. If we subtract 3 from 10 is greater than 4, we get 7 is greater than 1, which is still a true statement. So we keep the sign. If we multiply by 2, 10 is greater than 4 becomes 20 is greater than 8, which again is still a true statement, so we keep the sign. If we divide by 2, 10 is greater than 4 becomes 5 is greater than 2. Again, 5 is greater than 2, so we would keep the sign. If we multiply by negative 2, 10 is greater than 4 becomes negative 20 is greater than negative 8. Well, this is a false statement. Negative 20 is not greater than negative 8. So what we have to do here is we have to reverse the sign. So we would have to rewrite this as negative 20 is less than negative 8. And the last is to divide by a negative number. If we divide negative 2 by 10 at 4, we get negative 5 is greater than negative 2, which again is a false statement. So again, we have to reverse the sign. And we would have to reverse it to negative 5 is less than negative 2. So what we've concluded here is that whenever we multiply or divide by a negative number, we must flip the inequality sign. And we're going to look at some examples. Is this? Negative 7b plus 19 is less than negative 16. When solving inequalities, you solve them just like you would an equation, but you have to remember to flip the sign if we multiply or divide by a negative. So I'm going to subtract 19 here. This leaves me with negative 7b is less than negative 35. And then I'm going to divide by negative 7 to get b is greater than 5. Remember, because we divided by a negative number, we must flip that sign. It was less than, we have to flip it to greater than. For number 2, I want you to write it on your paper and work it out on your own, just like you would an equation. I want you to pause the video when I finish writing it, and I want you to work it out on your own. When you have an answer, go ahead and hit play and we'll check it together. So pause the video and work this out on your own. We have variables on both sides here, so I'm going to subtract 3n from both sides. Could have done a couple other ways as well. This leaves me with negative 18 is greater than or equal to 2n plus 21. I'm going to subtract 21 from both sides, which gives me negative 39 is greater than or equal to 2n. When you divide both sides by 2, you get negative 19.5 is greater than or equal to n. Another way to write this would be n is less than or equal to negative 19.5. If you prefer to have the variable first, that's fine. Just have to make sure you flip everything. Because we divided by a positive number, we did not have to flip the inequality sign. We could keep it the same. But if you do prefer to write it with the variable first and you need to flip it, then you would flip the sign as well. 3 is 3y plus 4 is greater than 2, parentheses y plus 3, close parentheses, plus y. Solve this one on your own and hit pause now. To solve this, we're going to do distributive property first to get rid of the parentheses. This leaves us with 3y plus 4 is greater than 2y plus 6 plus y. When I combine like terms on the right side, I get 3y plus 6. You might already notice that we've got 3y and 3y on both sides. And when I try to get them together, just like when we had equations, sometimes they cancel out. And we have 4 is greater than 6. This is a false statement, so we call this an empty set, or a no solution. Either answer would work. Because this is a false statement, there is no value for y that I could plug in to make that true. Number 4 is 13 minus 11d is greater than or equal to 79. Hit pause and work this out on your own. This is a simple two-step. We're going to subtract 13 from both sides, which leaves us with a negative 11d is greater than or equal to 66. We're going to divide by negative 11. But even though it is a simple equation inequality to solve, we do need to flip our sign because we are divided by a negative number. So our greater than or equal to sign becomes a less than or equal to sign. Our final answer is D is less than or equal to negative 6. You could also have written 6 is greater than or equal to D. That would work as well. Number 5 is 8 parentheses t plus 2 close parentheses minus 3 parentheses t minus 4 is less than 5 parentheses t minus 7 plus 8. Hit pause and work this out on your own. I've got a couple distributive properties that I need to use right now. I'm going to distribute the 8 to everything inside, which gives me 8t plus 16 minus 3t. This is a negative 3 that I'm distributing to everything inside. A negative 3 times a negative 4 would give me a positive 12. It's less than. I'm going to distribute a 5 to everything inside that parentheses and get 5t minus 35 plus 8. I can combine some things on the left side. I get 5t plus 28 is less than, on this side I can combine the negative 35 and the positive 8 to get negative 27. Again, you notice that the 5t is on both sides, and when we subtract these, they will cancel and give us 28 is less than negative 27. This is an empty set as well, because this is a false statement, or no solution. One more example. Number 6 is 3d minus 2 parentheses 8d minus 9 is greater than 3 minus parentheses 2d plus 7. Hit pause and work this out on your own. I'm going to first distribute the negative 2 to everything inside, and that's going to give me negative 16d plus 18 is greater than 3. This is like a negative 1 on the outside that we're distributing to everything inside. That's going to give me negative 2d minus 7. I can combine the 3d and the negative 16d to get negative 19. That would give me negative 13d plus 18 is greater than, I can combine the 3 and the negative 7. That would give me negative 4, and I still have the negative 2d. I'm going to add 2d to both sides to give me negative 11d plus 8 is greater than negative 4. When I subtract 8 from both sides, I'll be left with negative 11d is greater than, that should be 18. There we go. Be negative 22. And when I divide by negative 11, I get d is less than 2. Because we divided by a negative number, we have to change that sign. Our final answer is d is less than 2. If you are solving and you get an answer that looks something like this, 6 is greater than negative 2. This is a true statement. It wouldn't be a no solution because it's true, and it's not an x is greater than or x is less than answer. So this would be an infinite solution. Just like in an equation, any value for x would work. Although we didn't have any examples with that type, it is possible to end up with an answer that is a true statement and has no variables in the final answer. You've now finished the examples for solving inequalities. Raise your hand when you are finished, and Ms. Walsh will come assist you.